Okay, we are here for the second class of the 7th week, and let's start with the second example. Basically, we are going to see now this example, complex numbers. I've already copy-pasted the necessary codes, and we can start. So let me run the code first, and let's see what do we do here, or maybe I should explain what complex numbers are. We have seen them during your high school. So basically, complex numbers have their real and imaginary parts. And we write them like this: the real part, which is a1, plus I imaginary part, which is b1, the imaginary part, and I is the square root of -1, which is an imaginary number. It's not a real number. It does not exist in the realm of real numbers. So if we have similarly z2, which is a2 plus ib2, this is how we define z plus, which is an addition of z1 plus z2. Basically, if we add two complex numbers, z1 and z2, that means that I'm adding the real part of the first one and the real part of the second one, with the imaginary part of the first one, with the imaginary part of the second one. Okay, and this is my new z plus, okay, which is addition of two complex numbers. For the subtraction, I do the same. I subtract the real parts and the imaginary parts correspondingly. And for the multiplication, remember this formula. This is my real part of z star, where z star is equal to z1 multiplied by z2, okay? And this is the imaginary part, because we're going to use them in our codes. So C++ has many data types: integers, doubles, floats, etc. But we don't have complex numbers there. That's why we're going to define a class about complex numbers. This is the class. As you might have guessed, in the private section. So as private, we have two variables, the real and the imaginary one, which are pointers to doubles. And as public, we have the constructor, the destructor, the copy constructor, operator, equal, minus equal, operator, multiplication, and you might guess what they are doing. Then we have functions like set real, set imaginary, get real, and get imaginary. And we have the friend function, which is operator plus equal. This is, as you see, not a member function, because if it was a member function, it wouldn't have had two parameters, because member functions, as you see here, the operators have only one parameter, which is the right-hand side. And as I told you, the left-hand side is assumed to be the calling function itself. But if operators are free functions, then operators have two parameters, where the first one is assumed to be the left-hand side, and the second one is the right-hand side. Okay? Now, this is friend function, which means that it can access the real and the imaginary variables, the private variables, basically. Now, I've already written this class, so this is my class. Maybe I should minimize this guy. So this is my class, complex numbers, real, which is a double, imaginary, another double, and the functions. Now, let's go to the corresponding CPP file of the header, and let's see what do we have over there. As usual, we start with the constructor. With the constructor, we don't do anything. Just we allocate dynamically memory for the real and the imaginary variables. So basically, this is what we do over here. Not this one, this one. So I'm just creating a memory, dynamically allocating it, and assigning the addresses of the newly allocated double variables to the corresponding pointers for the real and imaginary. According to the definitions of the compiler, usually the values of those real and imaginary parts are 0, but it depends from compiler to compiler. Now, set real. How do we set a value? Well, we take that value and we make the real part star real. So real is a pointer, star real means that we access the value of that pointer, and we make this guy to be equal to the new real. Similarly, set imaginary, we take another variable of double type, and we set the imaginary to be equal to the new imaginary, okay? So basically, up until now, we have covered the constructor, okay? So I've covered the constructor, set real function, set imaginary function. Now let's say what getReal is doing. It's self-explanatory basically. I'm returning the real part and I'm returning the imaginary part, which are doubled. Okay, I'm using again star real since real and imaginary are pointers. So in order to access the value, I should use star in the beginning, the values to which the pointers are pointing. Okay, so we saw getReal and getImaginary also. If you see here in the ends, for the getReal and getImaginary, we have those const keywords. That means that getReal and getImaginary cannot change the state of the object. That means they cannot change the variables, the values of variables. That means if you remember it from CS201, getReal and getImaginary are accessors, not mutators. They cannot change the values, but they can access them. That's why we have those const over here. Okay, so far so good. Now let's see copy constructors. So let's assume I've created a complex number C1. I've set the real number, real part, which is 3, the imaginary part, which is -2. And I'm creating another complex number, another object of the class complex number. The name of that object is C2, and I want C2 to be an exact copy of C1. So remember, constructors are the functions that we call when we always create a new object. You cannot create a new variable or object of a certain class without a constructor. Now, which constructor are you going to call it? Something else. But if you want the object that you're creating right now to be a copy, a clone of another object which already exists, like in this case it's C1, then we are calling the copy constructor. And as you see, the copy constructor is taken as a parameter, which is a constant reference, okay? And it should be of the same type, same class, of course. Otherwise, you cannot make a clone of another class. And what do is the following. Always in constructors, you should dynamically allocate memory, and only in the destructors you destroy it, okay? So the real part is equal to new double, imaginary is new double. Basically, I'm just creating those two boxes, and then I just say star real. Now, star real is the real part of the calling function of the member for which we are calling, of the calling object, where we are creating this object, okay? And copy.real is the real part of the copy, okay? So basically, if this is my copy over here, they are the same class, same object. So if this is my copy, and if I've set this guy to be the values of this guy, the real part, the pointer to the real is 5, so this is 5. And for the imaginary part, maybe -3, okay? In that case, I'm making real, star real, to be equal to copy real, see? Star real is equal to copy real. That means that this is the calling object, so real, this guy is equal to copy real, so I'm making this guy to be 5, okay? And then star imaginary is equal to copy imaginary, star copy imaginary, since those are pointers. So this is what I do. In the end, as you see, I just created an exact replica clone of the calling object and the copy, as simple as that. Okay, we saw the copy constructor, which is this one. Now let's see other functions. Now we're going to deal with operators. Operator equal. Remember, when you're using operator equal, that means that this is not a constructor. The object already exists, and you want the existing object to make it to be equal to another existing object. And since this is a member function, we have only the right-hand side. So if this is my operator equal, right-hand side is this one, okay? Maybe I should do it like this. So if I want to make C1 equal to C2, the right-hand side is C2. This is my operator equal, and C1 is the left-hand side. But if the operator equal is a member function, then I should take only the right-hand side, as you see here, as a parameter, because the left-hand side is the calling function itself. Okay, so what do I do over there? I do pretty much the same as with constructors. So now this is not the copy, this is my right-hand side. Let's say this is the object that already exists in my memory. So this is right-hand side. And I want to make a copy of this guy. So basically, instead of 5, and let's say if I don't have, I have other values, I just put here 5 and 3. And I do it with those lines. So real is equal to real right-hand side dot real, and imaginary, star imaginary, is equal to right-hand side imaginary, okay? However, as you remember it from the previous class, and for the same reasons, in the end, so right now, if I do just C1 is equal to C2, as you see, I've made C1 to be exactly equal to right-hand side, which is C2 in our case. Okay, I don't have to do anything. So -3, why didn't I do it? Okay, -3, let me write it. -3, okay. So the left-hand side, right-hand side are now the same. Basically, I've done my job. However, what if I say something like this? C3 is equal to C1 is equal to C2. If I don't return any value during the operator, when I finish the operator equal, then I'll say C3 is equal to nothing. And it's a compiler mistake. That's why I should return this. And what was this? Again, I'll explain it. So when you are dealing with declaring and defining a class, there's always an operator which is called this. And it is pointing to the object that I'm creating now, okay? So basically, when I say return star this, I'm returning the object itself for cascading purposes, okay? So I can use something like this, okay? Now, when C1 is equal to C2 is finished, then I can say, well, C3 is equal to what this guy is returning. And what it's returning? Well, it's returning the object that previously called the operator equal. As simple as that. And why do we do this this condition here, if this is not equal to right-hand side? Well, the reason is simple, because sometimes I can do something like this, as I explained it to you. C1 is equal to C1. And if I want someone to be equal to itself, well, that guy is already equal to himself, so I don't have to do any further changes. That's why I do this check. Furthermore, as we saw it in the math vector example, if I delete the vector, and then if I try to allocate the same vector to make a clone of the same vector, I will not be able anymore to do it because I deleted the original vector. That's why if this is equal to right-hand side, basically if this is equal to the right-hand side, if they are the same, I don't have to make any changes. Otherwise, of course, I make changes. So this is operator equal. Now let's see operator minus equal. Again, this is a calling function, member function. So I should have only the right-hand side, and the left-hand side is assumed to be the calling object itself. So what do we do over here? Well, the real part is equal to real minus right-hand side, gets real, and imaginary is equal to imaginary, right-hand side, get imaginary. You remember the get real and get imaginary functions, member functions that we already explained. So basically, this function, if this is my left-hand side, I want this guy, the left-hand side, so let me write it, this is the left-hand side. I want this guy to be minus equal to the right-hand side. Basically, I'm adding values according to the minus equal operator that you have seen in C++. So that means if the values are, I don't know, maybe here it's, let me change the values. So if the value of this guy is maybe 2, and of this guy is maybe 5, then what I'm doing is the following. I'm setting this one, 5, to be 5 plus 2, it's 7. So this guy is now 7. I'm sorry, 5 minus 2, it's 3. Because it's minus equal, so it's 3. And this guy is minus 3, minus 5, it's minus 8. So I'm changing the values of the left-hand side. So it was minus 3, minus 5, it's minus 8. Okay. This is what I do with those two lines. And finally, for cascading purposes, again, I return a reference, a constant reference to the object, the calling object, the object that is calling minus equal. Constant reference means that I cannot change it, okay? And I don't create a copy of it. So basically, I need it for those kinds of operations. C1 minus equal to C2. So first of all, we will see it actually. C2 minus equal C3 is going to be executed. Then I'm going to return C2 as a constant reference. And C2 will be an entry point for minus equal of C1. And you see, I'm returning a constant reference, but I'm also taking a constant reference as a parameter. So C1 will take the return value of C2 as a constant reference, and we'll continue on. So this is operator minus equal. Let me check it. So operator equal was done, minus equal was done. Let's see operator multiplication now, and let me show you the initial picture in the beginning. So this is how we did the multiplication. Remember this formula, okay? So the real part of the multiplication of two numbers z1 and z2 is basically this one, and this is the imaginary part, okay? So how do I do that? Let's see the code. Again, since this is a member function, operator equal, I'm just taking the constant reference of right-hand side. Then inside I'm creating a result. I'm defining two doubles for the real and the imaginary part. Then using the formula, this one, this is for the real part, and this is for the imaginary part, okay? Here how I calculate the real part, and let's not forget that the left-hand side is A1, okay? The calling object is the real, that's why I just say star real, which is the calling object, and I get the real of the right-hand side. I do the same for the imaginary, and this I calculate the real of the result. And the imaginary of the result is like this. Finally, those two doubles, I set them to the result using the set real and the set imaginary function. And now I'm returning the result, but as you see, it's not a constant reference. Okay, I'm returning the complex number, but I'm returning a copy of this guy. So basically what this function is doing is the following. So this is my right-hand side, this is left-hand side, and this is operator multiplication. This is the result that I create inside of the function. And what I say, well, I just calculate this formula, real, star real multiplied by right-hand side real minus blah, blah, blah till the end, okay? And after I do calculations, I put the values here. I don't know, maybe it's, let's say, x and y. There are some concrete values, of course. And finally, I return the results. But when I return the result, I don't return a reference. I return a copy of it, okay? And when I return a copy, I always call the copy constructor. So let's explain this part. Always, when you call a function and it takes a value, not a reference, always you send a copy, and you send a copy of a certain class or object by calling the copy constructor. The same applies when you return something. This is very important, so I'll underline it, please. The same is the case with returning values. If you return something which is not a reference, okay, then you return a copy of it. And how do you create a copy of a certain object? Well, you call the copy constructor, okay? And we will see it in the examples later on. Finally, we have the destructor. So when you don't need the object of a certain class, you just destroy it. And how do you destroy it? Well, in the constructors, you just dynamically allocate the real and imaginary. In the destructors, you just delete it. As simple as this, in order not to have memory leakages. Okay, now we saw this part, but we didn't see the member function, friend, if you remember, which was operator plus equal. Now you see all of the operators, equal, minus equal, etc. They took only one parameter. It was the right-hand side, this one, because the left-hand side, as I explained it, was the calling object itself. However, if the functions are free functions, like this one, operator plus equal, which is a friend, plus friend means I can access the real and imaginary data or private data without any problem. But this is not a member function, it's a free function. Well, the free functions, as you see, we have operator plus here. Then we have another operator plus equal, this one, which was the friend function, this one, operator, output stream, input stream, etc. All of them take two parameters, those kind of operators. So operator plus equal now takes the right-hand side, this one, and the left-hand side. Because now it's not a member function, so the left-hand side cannot be the calling object because it's not a member of any object, so it can be called from the object itself, okay? That's why we need here, for the operators, which are free functions, two parameters, the right-hand side and the left-hand side. Now you might ask, which operators should be member functions and which should be free functions? Well, the general rule is it's up to you. You decide about it. But if you make it a free function, it should have the right-hand side and left-hand side. If it's a member function, it should have, I'm talking about binary operations, by the way, it should have only the right-hand side because the left-hand side is the calling function, the calling object itself, okay? But there is an exception of this rule, and this applies to output stream and input stream. They must be free functions. They cannot be member functions, and we will see why. So let's go now with operator output stream. So we are now in main CPP, and here we have the operator output stream. Now we know how to print. Actually, it's coming with a package of the compilers for C++. We know how to print an integer, a double, a float, etc. We don't want to know how to print a complex because we defined it. Well, we are going to define now how to print a complex number. And always, not only for the complex numbers, this is what we do. We take as an input, as a parameter, a reference to output stream, and it must be a reference. And maybe a constant, yeah, usually this is the case, a constant reference to the class that we want to print. We make it a constant reference because we don't want to change it. We just want to print it. So how do we print it? Well, inside, if the imaginary part, and we take the imaginary part using the getImaginary function of the complex object, is smaller than 0, then we just print the real part and the imaginary part. In the end, we add the I. Okay. Why do we? And if it's not smaller than 0, then we add plus. So basically, if the numbers are positive, you know that the compiler doesn't write. So it doesn't write the plus sign. So if it's 5, it doesn't write it's plus 5. It's 5 only. But if it's negative, we write the sign. Write the sign. That's why if the imaginary part is positive of a certain number, complex number, we want to write the plus only for the imaginary part. That's why we explicitly write it. And finally, we return this output that we get. So in this output, you see here, in this output, we just append stuff that we want to print, and we return it. And when we return it as a reference. It's a must return it as a reference. And it shouldn't be a constant, because if it's constant, you cannot print other stuff. So why do we need this stuff? Basically, let's assume we have a complex number Z1. Then I'm setting the real part to be 5, the imaginary part to be -2. Then I have an integer 9. Now, very often, with one cout command, you might want to print multiple variables and objects. So you print a string whose name is blah, blah, blah. This is string, by the way. You print the complex number Z1, or you print this integer A. Okay, so what's going on? You see, when I print blah, 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 this is already my output. So when I want to print it, this part over here, Z1, I'm taking an O stream, okay, reference of it, and that reference is basically the reference where I'm printing blah, 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 which is a string. Okay, so this is my output. It shouldn't be a constant because I'm going to change it. I'm going to append, as you see, extra stuff to it, other stuff to be printed to the output stream. That's why it shouldn't be a constant, but it must be a reference, because if it's not a reference, as I told you, I'm going to send a copy of the output stream. And when I send a copy of the output stream, I might lose this blah, blah, blah. Okay, so it must be a reference for this reason. So I print blah, blah, blah. Now it's the turn of Z1. And how do I print Z1? Well, we already see it. And then I return the output, and it must be a reference, because if it's not a reference, I'm going to return a copy of it. And I don't want to return a copy because I want to print exactly that object. But I don't want the reference to be a constant, because if it's constant, I cannot add other stuff, okay? And so after I return Z1, okay, which is printing blah, blah, and it's printing the real imaginary part, I want to print the integer A. That's why I return it, for cascading purposes, okay? And finally, I print end line, okay? So this is operator O stream. That's why operator O stream cannot be member function, okay? Because it's kind of a public function or operator for all the variables, not only for a certain variable, okay? Well, the same goes with the input stream. In my input stream, as you see, I take, for the same reasons, a reference to input stream and the complex number, but it's not a constant, as it was the case over here. Why? Because I'm going to change the values of these complex numbers. I'm going to add the real and imaginary part, but it should be a reference, because if it's not a reference, I'll get a copy, I'll change the copy, but not the original one. So it must be a reference, which is not a constant. What do I do there? Well, I declare two doubles, real, imaginary. I read real part, I read the imaginary part. In this complex object, I set the real part, I set the imaginary part, and then I return, again, a reference for the same reasons that I explained before. Okay, I take a reference and I return the reference. And those references of input file, I stream, either when I take it as an input parameter or when I return it, should be references which are not constants. Because if they are not references, I'm going to change not the original one, the copy one. Okay, and if they are constant, I cannot make changes to them. Well, basically, I need it again for cascading purposes. So if I have a string and in the same scene, I want to read multiple variables or objects, I want to read first the name, which this is my input, okay? After that, I want to read zi, okay? And this is how I read zi, I've defined it. And I return this one as a reference. And then I want to read a, which is another integer, which I've defined before, declared before. And this is how I do it, okay? That's why our stream, I stream should be references which are not constant, both for their input or the returning value. Okay. Then we have the operator plus. Operator plus is, again, it's not a member function, so we have the left-hand side and the right-hand side. Okay. They are constant because we don't want to change their values. But we take them as a reference. What do? I define another complex number inside of this free function. And I have the real result and imaginary result. Basically, the real result is the real part, as I showed it to you, is equal to the real part of number one, of the first complex, plus the real part of the second number. The same goes for the imaginary part. But see, the operator plus is not a friend function. So I cannot access the private variables. But what I do is the following. I can access the private variables using the public functions, which were get, real, get, imaginary. And then in the results, I can set them using set real and set imaginary. Those are all also public functions, so I can use them. And finally, as you see here, I return a value, but I don't return a reference or constant reference. That's why when I'm going to return this one, I'm going to call the copy constructor. I return a copy of this guy. And finally, I have the plus equal operator, which, if you remember, was a friend function of the class complex class. That's why here I can access the real and imaginary parts without any problem. What is plus equal doing? It's self-explanatory. Basically, to the left-hand side, and since this is not a member function, I should have the left-hand side and the right-hand side, which are const. The right-hand side is const because I don't want to change it, but the left-hand side is not const. And it must be a reference because I'm going to change it. And how do I change it? Well, I set the real part of the left-hand side to be equal to the real part of the left-hand side plus real part of the right-hand side. And the same goes for the imaginary part. It's the simple plus equal operator. But we do it component-wise, both for the real part and imaginary part of the left-hand side. That's why the left-hand side is not constant. And it must be a reference because I want to see the changes in it, not in the copy. But the right-hand side, I can take it as a constant reference because it shouldn't be changed. Finally, when I return the left-hand side, so here I make the changes, but when I return it, I don't return it as an object, as a copy, as a reference. I return it. That means that I cannot change it anymore. But inside of the left-hand side, it should be changed according to the plus equal operator. So this is all. This is what I explained right now. So I explained the friend operator plus equal. I explained the output stream, the input stream, and operator plus. All of those guys, operators, were free operators. They were not member operators. And when they are free, as operator output stream and input stream, those two, they must be always free. But the others, plus, equal, or plus, they can be member functions or they can be also free functions. It's up to you to decide. Again, if they are member functions, they should have only one parameter because the left-hand side is the calling object. And if they are free operators, then you should have two parameters. As you see here, I have the num2 and num1. Basically, this is my right-hand side, and this is my left-hand side. Okay, for the operator plus. Finally, let's do some manipulations and let's see how this class works. And I'm going to use breaking point. So I'm running the code now. Let's see when I call the constructor. So I'm starting. Okay. the program is being built. Okay, so I'm getting my output right now. Let's see the output. Let's have the output and the code close to each other. Okay, so let's have me up there. You don't want to see me right now, never mind. So we are starting with the first line. As I did in the previous class, I'm going to run debug step into. So I'll show the step into part when I'm going to go inside the functions. So step into, you see, I'm declaring two variables, C1 and C2. Okay, so if I say debug step into, I'm going to call the constructor, default constructor for C1 and C2. Why it's default? Because it doesn't take any parameters. So debug step into, and I'm calling the default constructor or empty constructor as you wish. If I go step over, so step over is just to go one by one through the lines, and step in is to go inside if there are some other calling functions. So step over, and if you see this yellow arrow going through codes, that means I'm using step over. And if I'm going to step into, I just show it to you. So I'm using now F10. I'm setting the real part, the imaginary part, and I'm overdone. But I've done with C1. Now I should do the same with C2. So that's why I go debug, step into, real part, imaginary part. I'm finished. I do the same with the next line. Okay. Now I go in this line where I'm going to print enter two complex numbers, first real, blah, blah, blah. So I'm printing this as you see the output. Now I'm reading in. I'm reading the first one and the second one. That's why I go debug, step into, and you see this is operator O stream. So now I want to read the real part. And here I should enter the real part. Let's say the value of the real part is 5. I should read now the imaginary parts over here. So I'm step F10, step over. And here I should give the imaginary part as an input. Let's say it's -2. Then now after I have read them, I should, using the setReal function, let me not use step into because we know we are calling the setReal function. So I set the real, set the imaginary, and I return the input, which is a reference. I don't call copy constructor. I'm finished, but I'm finished with C1. And that return input that we saw previously is going to be as an entry point for C2. That's why if I go debug, now I read C1. I want to read C2 in the same fashion. If I say step into, I do the same stuff, but now for C2. So I'm reading the real part of C2, which is, let's say, maybe -3. And the imaginary part of C2, which is, I don't know, maybe 7. Okay. Okay, it's 7. Now I'm setting the real. I'm setting the imaginary, -3 and 7. I'm returning the input. So I'm finished with this line. I go to a new line. You'll see the cursor to a new line. Now I should print C1, but before that I print a string. And this is the cascading, what I was talking about. So first of all, I print the string. You have never seen it, but if you want to see how you print a string, actually it's already embedded in the compiler. When you say using namespace std, etc., you have it inside. So, or input IO stream, well, it's inside over there. So let's see how do we print a string. We are going to see weird code. Maybe it looks hard. Okay, so this is how you print a string. Of course, we're not going into details. Maybe it looks too hard, but it's not that hard. It's understandable. That's why let's go step out. So we print first complex number, this one. Now we should print C1. How do we print it? Again, debug. So we are finished with printing this one, but we are not finished with this line, with this comment. So now we print C1. And this is the cascading printing that I've been talking about. Again, I go into step into, and let's see how do we print a complex number. Well, I'm using F10 now. If get imaginary smaller than 0, and it's not, then I print it, and this is how I print it. You see the output. Then I return the output in order to print the end line, and this is it. I do the same with the second line. I print it like this. Now, let's see how this guy works. C1 plus C2. First of all, I'm going to execute C1 plus C2. So debug, step into. And you see I don't call the copy constructor here because I'm taking both the parameters as a reference, constant reference. So here I create a new result. I just said calculate the real, the imaginary part. I set the real part, the imaginary part. And now when we are the result, you see here, I return the value as a constant reference, not as a constant reference, as a value. Since I return it as a value, I'm going to call the copy constructor over here, okay? And that's why if I go debug, step into, you see, I'm going to the copy constructor. So I set the real, the imaginary here, copy real, imaginary, and now I'm returning the value, and this is it, okay? Now I'm finished with C1 plus C2. And the returned value, which I returned it using the copy constructor, is going to be an entry for the operator equal now, okay? That's why if I say debug, step into, I'm inside of the equal operator, and I don't make any copy here because the right-hand side is taken now as a constant reference. Yes, return the copy as a copy constructor, but after we return the copy, that copy is now constant reference, so I cannot change it inside the function. So I go with the operator equal, and now when I should return this, you see I'm returning a constant reference, not a parameter. That's why if I say build as a debug step into, I don't call the copy constructor because I'm returning a reference. Okay, and this is it. So I print now the first plus second, the results. This is it. Now let's see operator minus equal. So debug step into, this is operator minus equal. I set the real part, the imaginary part. I return the value as a reference, so no copy constructor. Then I print, what should I print? Then I go with the multiplication. First of all, I'm going to do this part, and then the equality part. So debug, step into, okay. And operator equal was member function, so I have only right-hand side. I don't call the copy constructor because it's a reference, so I do this part here. And the result should be returned, but the result, you see, it's not a reference, it's a value, so I'm calling the copy constructor now before returning. I return the created copy, and operator equal is going to use the returned copy now. So if I go again step into, I'm dealing with operator equal. And here, I'm returning a reference. So if I say debug step into, there's no copy constructor because I'm returning a reference. Finally, here we have the cascading plus equal. So if I say debug step into, I'm using the first cascade. Again, if I say, and I'm using the second one, debug step into, this is the second plus equal. And finally, I should use equality operator. So debug step into, this is the equality operator. And I'm printing the guys, and I'm over. Okay, so this is it with debugging with the class. We'll have a break of 5 minutes, and we will be back in a while, okay? You can use the link to connect.